So the next thing I want to go through is designing and working with objects. So this is really just rounding out the stuff we've talked about. I've shown you how to make objects and classes, but that's not the same as knowing why you make objects and classes or when it's a good idea to do so. Unfortunately, there isn't really a way to just say what the answer is, right? So there isn't just it's because of this or it's because of that. So it's about practice, and I'm also about sort of thinking about the problem a little bit. So in this section, we've got a little bit on the terms because I also realise that we throw a lot of these things around, and in many cases there are multiple things for the same term. There are probably more than I've thought of here that you might come across, but they're maybe a little bit less common, or maybe my memory's just not good enough sometimes to remember all of them, because there are certain ones that are used a lot. Some are used in specific languages, particularly, and so on. So if I see any more, I'll put them in the list. In fact, I might even move this list across the quick start guide somewhere so that we can keep it up to date on there. But I just want to run through them a little bit just to clear up what the definitions are, and so that if you hear me call things a member, a method, or a function, or whatever else, you know that I'm possibly talking about exactly the same thing, no matter which one I say. So first of all, class and object. We talked about this already, but the class is the template. Okay, if you like, it's not just the code; it is the representation in the running version of the template from which objects are made. So we define
you're not
the
showing
class.
your screen.
Oh yeah, it's a useful thing to do. Thank you to whoever that was. There we go. So the first one is class and object. So the difference between these is one of them is the template from which the other is made. The class is the template. The objects are the instances of that class. So what that means is we make an integer. An integer is a type of thing, and then the actual numbers themselves, 1, 2, 3, 27, and whatever. These are the instances of that. Now, in Python, that is literally the case. There is a class for the integer, and the numbers that we use are literally instances of that. So once they're in a variable, they're an instance of it. So that's useful. In other languages, not always the case. So sometimes you have what they're called basic types, which are things that are just regions of memory. We talked about those. That wouldn't apply in those languages. We also talked about members. So members are the attributes and methods of a class and object. So the data about that's inside them and the functions that they have. And then we have the method, which is a member function of a class or object. So something's a method, it is sometimes called a class function or an object function, depending on whether it belongs to the classes or the objects. Generally, in this module, you're going to see nothing but object functions. Next year, you might explore a little bit why we would use some class methods, but for now, we're not going to worry too much about those. But method is another word for a function that is part of a class or an object. Okay, so when we say, say we've got a list called A and we do a.reverse, that's a method. Okay, if we said def reverse and we made a function for reversing arbitrary things, that would be just a plain function. It wouldn't be a method that's usually reserved to describe a function that's associated with a class or an object. We then have two words which are sometimes used, not so much in Python, but sometimes called accessor and mutator. These are just methods or object functions that allow you to access or change, mutate, the contents of the object, so the variables that are contained. Okay, so sometimes these are also called getters and setters. In many languages you have to provide these to stick with the convention or even the rules of the language. So be able to say get age and set age would be the way you set an age variable. In Python, it's actually much more common that you would just go in and change the variable itself. There are very different opinions on whether one way of doing it is good or not, and you can do both things in Python. Python programmers tend to go with the idea that you don't need that kind of level of control over access unless you think it's likely to cause problems. Whereas if you're doing something, say, in Java, you'd be much more concerned about, strict isolation of the inside from the outside. You would make sure that encapsulation was really, really well adhered to. So these getters and setters mean the same thing. Attribute, these are the variables that are associated with class or an object. So if we have a person object, it's got an age, then age is an attribute of that. Sometimes they're also called instance variables. So it could be an attribute, could be an instance variable, could be a class variable or object variable. All of those mean the same thing. Object function, method applied to this. So again, this is the same as essentially a method, but it's a method that's definitely part of an instance this time, not the class. And you can tell what these are. These are the ones that have self as the first parameter, okay? Because the self bit is how it's associated with that particular instance. And a class function is one that doesn't have that. We're not really going to see those, but they're there just for completeness. Same with class variables, okay? Instance variables is another word for attributes, but belong to the instance. We keep talking about instances, which is just, if you have an object, it is an instance of the class it was made from. And so the process of creating those is called instantiation. We then have constructors, which you've seen. These are the ones that are called init. These are the methods that are in there, or the object functions called init. They're called when we create a new instance. So when we create a new thing, that gets called. Again, you've seen this one. The one you haven't seen is the destructor. You don't often see them in Python for a couple of reasons, mostly because Python's got garbage collection and not really any need for anything that happens when it's garbage collected. Garbage collection is, we make variables and stuff in Python, we make objects, and when we don't need them anymore, they just go away. All right, so if we stop referring to them, as in we no longer have the name for them, like A equals person. If we say A equals something else, that person object disappears. Okay, we don't need to remember to go and delete it. Not all languages do that. So if you're doing this kind of stuff in, say, C or C++, you need to be aware that you have to get rid of memory. Obviously, you wouldn't be making objects in C, maybe Objective-C, but you'd still maybe allocate memory and that kind of stuff. And you can do the same things in C++. And if you don't unallocate it and free that memory up, and you lose the reference to the object, that's what's called a memory leak, and it just takes up memory because you're essentially just having areas of memory that are allocated that you can no longer refer to. So it's there for completeness, not really a big deal in Python. Sometimes we talk about parent and child. This is about inheritance. So the thing that you inherit from is called a parent, and the thing that inherits is a child, or the parent is sometimes called a superclass, and the child is sometimes called a subclass. Okay, all mean the same thing. Okay, so lots and lots of terms, and these are here mostly as a reference. I've gone through them fairly quickly. Don't worry about trying to memorize all of these things. Context, in my experience, context makes these things obvious. Okay, if you ever think, I don't remember what that is, you can go and look it up here, but honestly you could probably pick it up from context anyway.
James, just a quick one, sorry. You just mentioned destructor.
Yes.
Is that by any chance garbage collection, or am I thinking of the wrong thing?
No, so the destructor will be called when the object is destroyed, which is probably going to be when the garbage collector picks it. Okay, so if the garbage collector comes along and realizes nothing is using that anymore, I'll get rid of it. It will call the del function and do it there, but it's not actually garbage collection, if that makes sense.
Okay, I'm with you.
Yeah. Okay. We can get into that more if you like at some point, but maybe save it for one of the support sessions when we've got a bit of time.
I've actually started writing an example that includes it for the quick start guide. So
okay, just to fill it. Brilliant. Thanks. Yeah. Thanks, Dan. Adam.
It's all right.
I can tell the difference between your voices as well. So it's just...
yeah.
Right. Okay. So we've got a couple of bits to go through in here. So firstly, when we say object-oriented design, there's like an extreme end of these things, right? So there are people that will design everything with objects, and generally they're thinking in larger terms of software. So like, building large bits of applications, things that are thousands of lines of code and involve multiple people. it's great, right? It's absolutely brilliant. But this isn't software development or a programming course. It is programming for ethical hackers. So, we're not going to get into that sort of, everything must be done in this particular way. Every object must be, designed along certain things, and everything must be object oriented. For us, it's more horses for courses, right? So if the object oriented approach is going to work for us, let's use it. Okay, it is not difficult in Python. It's probably, I can't think of another language that makes it as intuitive and simple to use objects as Python does. So we'll pick them up when we need them, and we won't feel obliged to use them if we don't want to. Okay, so in small scale, we don't have to use it, and a lot of the things that we're doing here are small scale things. So you might think, well, some of these programs are bigger than you've ever seen before. If you just started programming, you look at the amount of code I've provided that behind the scenes, it's still not big. Okay, big is 10, 20, 100 times bigger than this, right? So we don't have to use them all the time, but that doesn't mean it's not useful. So why do we use object-oriented programming at all? Generally, when it makes the code easier to understand, when it simplifies the design, okay, when you can actually use it to design the code nicely, okay, to make things more reusable, so we can write things that are easier to pick up and use again and save a lot of effort, and also save us a lot of debugging. So getting things correct and tested is really important. And if we can reduce the amount of code we write, we reduce the amount of errors that we make, and also for easier team working, right? If you say, right, you need to write an object for this and I need to write an object for that, these are the things they can do. You don't actually need to know how those objects work internally. That's where encapsulation comes from, to use them. Okay, so it actually helps you work with other people. Potential negatives, you can add lots more lines of code. Okay, so on the other hand, if you're writing objects and they're not really necessary, you could be adding quite a lot more lines of code to your software. And my philosophy has always been every line of code that you write is a line of code that you've got a chance to make a mistake on. So try to write fewer if possible. That doesn't mean write things that are intentionally obtuse and difficult to read. I just mean don't over engineer if you don't need to. Reuse things wherever possible. But you can actually end up writing classes. There's this class explosion that you sometimes hear people talk about is this unnecessary bloat. You start building more stuff, and you can end up over engineering. You can spend time building things that perhaps don't need to have that much effort put into them. Sometimes what you want is a quick and dirty 100-line script. And in this module, that's actually fine. Okay, so that might well be exactly what you need. It's as long as it's tested, as long as it's readable and those things. I'm more interested in that than having these big frameworks of objects to put together. Okay, so all that aside, I do use objects a lot, and they are very, very useful. So we're going to look at some examples now, and you're going to look at for your breakout and your sort of project work for this week until next Wednesday is going to be using that in the Exfiltrator project. And then next week, you're going to start on the Leap project, and that's going to use objects quite extensively. Okay, so how do you work out what should be an object? And I'm going to show you an old trick that I do not want you to apply blindly. So when I was taught object-oriented programming, it was in the early days of OO, and I literally was asked to sit and, as an exercise, was to go through paragraphs of software specifications. So I did software engineering as my first degree. I would go through pages of stuff, highlighting things and underlining things, and to identify stuff. And even then, I realized that this was maybe useful as a sort of help to a programmer, but if you apply it blindly, leads to some very, very stupid mistakes. Okay, things that just aren't necessary, like bad designs. You just don't need to do it. So with that warning, this is the trick. Nouns in a specification might be objects. Okay, things that describe, identify or compose them might be attributes of them. Okay, so this is my modified version of these rules, so they're a little bit less strict and a little bit more broad. And here, sometimes verbs might indicate object functionality, but in reality, I don't think this is actually that useful, this part. Okay, so verbs in a specification, I almost 90% of what see don't need to make functions for objects. They don't make good methods. But that was one of the things that I was made to do when I was learning object-oriented programming. Don't recommend it. Okay, so this thing's not necessarily a bad idea, but just do not apply it blindly. Okay, so just use it to help you think about stuff, and then from there, think about what you want. Okay, so here's a specification for some software. It's actually just a little piece of a larger piece of software, but it works. A game character has a name, can hold a number of items. Each item will have a name, description, and weight. The character's strength determines how much can be carried. The maximum is strength 5 kilograms. A character is unburdened when carrying less than or equal to a quarter of the maximum, lightly burdened at or below half the maximum, heavily burdened at or below 75%, and struggling above 75%. Okay. Now in here, I've underlined potential objects, and I've italicized things that are attributes of objects. Okay, so things that I will use as attributes. So you can see here, a game character, okay, has a name. So the character is the thing that I'm going to make an object of, and it has a name. So that's something that describes it. So I said here, things that describe, identify, or compose. So name can hold a number of items, or item. That's another thing that's in there. Each item has a name, description, and weight. Again, descriptions and composition of what's there. Character's strength, so that describes the character. So let's put that in as another potential attribute. Determine how much it can be carried. But you can see things like carried. Yeah, these are verbs. Burdened, unburdened. Are these attributes? Well, if we think about it, they are sort of things that we can calculate. And so I wouldn't put them in as attributes, because it's more about we can calculate whether someone's burdened or unburdened. So this is more a description of how we process the data. And so this example shows you why you shouldn't apply any of these rules blindly. Okay, so it can help, useful, but I would say that's about it. Dan, did you do this stuff in object-oriented programming when you were being taught?
You taught me it, mate.
Oh, so I probably didn't make you do this, did I?
But no. At uni, we didn't do it like this because you and Sarah taught us. But at college, we did sit and go through this way of doing it, and I'm not massively keen on it myself. I mean, it sort of makes sense.
It does, but I think it comes from when OO was first coming out. There was this big push to turn software creation into an engineering discipline, where you would basically put in an application, crank a handle, and then you'd get good software out the other end. This was the attempt to solve what they used to call the software crisis.
Yeah, this is why we had UML and all of that stuff crop up as well, didn't we?
And those things can be useful, but I think applying them blindly is always iffy. Anyway, just a bit of an aside really on the origin of these kinds of ideas. So what we might come out with from this, and this is what I implemented from that description, is I made two classes, right? So these are two things I underlined. One's called character, one's called item. Notice the capital letter at the start. That is not anything more than a convention. You could start them with lowercase letters, but I will absolutely mark you down on the elegance part of the coursework, because it's useful. And in fact, many languages have exactly this kind of convention, which is classes start with a capital letter. All right, it means you can tell when something is a class name, and therefore you can tell whether you're instantiating a class when you have like character and then an open and close bracket to create one. That's not a function, that is an instance of a class being made. Okay, so just really simple thing. But we have this class, and then we indent the same as before. Everything that goes inside is indented. In both of them, all I've done is put the constructor, and you can see the constructor takes self, as all of the object methods will, and then any other data that you want, so name and strength. So essentially we're saying, right, make a new object, and it will need a name and a strength value. So we say self.name is name, self.strength is strength. So now we'll have that instance. And so later when we say A equals character, open bracket, James 5, that would be making a character where the name is stored as James and the strength will be stored as 5. Okay, and then we could say B equals character and give it different details, and A and B will have different name, different strength, but they will have the same sort of functions and stuff that can be used on them. And then we have the item. Exactly the same thing here, just passes 3 pieces of data in, name, description, and weight, and each of those gets stored. So you'll see this kind of thing is quite common. Self.name equals name. Self.name means this object attribute is going to be called name, and we're going to store in it whatever's in this name variable here. It is possible, and some people would argue it is preferable to have a different name for these things, just for clarity. I've never really seen that as necessary, because I can see here that self.name is self.name, so it's belonging to the object, whereas name here is referring to this one because it's not prefixed by self. So they are different things, they just happen to have the same name because that makes sense, right? It's helpful to know that these things match up. Okay, so that's a basic thing, and that's the old trick of identifying. But what else do we need to do? I mean, this is not all that happens. We need to think about what else happens. So far, most of what we've done has been working bottom up. We've started writing code by thinking, well, what do I know how to do? What's the small pieces that I can build and then start putting it together? So you think it's a big problem. Smallest piece of the puzzle is this. I'll definitely need that. Let's start with that. Then, how do I do the next bit of the puzzle? What's the next thing I would need to do? And can I put those two things together to make the next piece up? And so, one function might call another function and so on. Now, this is a bottom-up description, okay? Sometimes it works well, and actually in many cases that's all you'll really need. It seems fairly obvious. You build a few of the basics and you start putting them together, but in other times it can lead to a lot of disparate and scattered functionality, particularly with larger software projects or larger problems. You might not have a clear goal when you start doing that, and that can lead to potentially poorer design or things that are more difficult to reuse. So the other way to do it is something called top down, and there are many ways to do top down. We're going to talk about functional decomposition, which is probably a description in a general sense of almost all top down things. The simple concept here is that you start with a big idea and you break it down into chunks that make sense, okay? And by make sense, I mean there's a bit of intuition in there, there's a bit of common sense and a bit of experience that you bring to bear on it to go, well, that makes sense. To me that makes sense. It feels right, to make those as objects because they're the things I'm working with. Common sense will tell you that a lot of things are a good idea or not a good idea. If you see things and you think, well, I can make this object and this object, but they must always be used as a pair. Perhaps that's not two separate objects, but one object, and then the more experience you have, the easier it gets. So each of these chunks, each of these pieces of stuff that you're working on should have a clear input and output. And I put quotes around input and output in here because I don't mean input and output in the sense of what the user types or what comes from a file and things like that, or what goes to screen. Really what I'm talking about is the preconditions and postconditions, which is the official terms for what I'm talking about. And what that is, it's the condition or the status of the data and the program before and afterwards. Okay, so if you say, right, if I want to do this, I expect to be given some data as a parameter or in an array stored somewhere or whatever, and if I'm given that, this is what will happen. That's what I'm talking about here. So each chunk should be clear on what it needs to operate on and what comes out of it. Okay. So when we look at this, we can say, right, so what are the inputs and outputs? Well, actually, there's not really much relying on this because at the moment they don't do anything. Okay. As we start to add some functionality, you'll see that we're going, right, this will operate on the data that's held here. So this could be the precondition for other functionality, and the post condition is going to be what we expect to happen after we've used it. Okay, so these chunks then can be further divided. I'm talking about objects in this session, but actually this works even without object-oriented programming. It's just that because we're getting up to the kind of scale where object-oriented programming is useful, we're talking about these larger chunks. So you can divide them up even further. So if you say I need to do something that creates all of the pay slips for a company, okay, you go, right, so something to make pay slips. Well, let's divide that up. I'm going to need something that fetches all of the records. So let's divide that up. I'm going to need something to talk to a database. Okay, I'm going to need something that represents an individual record. I'm going to need to be able to calculate the pay for an individual record. So you're breaking it up into smaller pieces, and you can do that to every bit of the software. This is This is the functional decomposition. You can keep going until you get these chunks that are either sensibly sized for what they do, or they're small enough to be trivial, right? So one of those two things will become true. So if you get down to, well, I've got something that represents a person's record, do you need to break it up any further? Maybe that's a good chunk of code to become a class. Makes sense. Make objects of that. Or you've broken it down so far that you've got something like, retrieve a record from the database. Well, you probably don't need to break that one down any further. You've broken it down so far. You've got connect to the database, log into the database, retrieve a thing from the database, close the connection to the database. You're not going to break that down much further than that. So maybe that's small enough. Okay, so they're trivial. And object-oriented programming does work well with this method because objects are larger chunks of things. They're not like functions. They contain functions and data. So they do tend to work this way round. If you think about designing something with object-oriented programming, starting with a larger set of requirements and dividing it up into big chunks and into chunks from there tends to be a better way around with object-oriented programming. So let's go back to our running example. A character has to hold objects and be able to determine if it being the character is unburdened and so on. So the first level of decomposition surely is we need a method that adds to the inventory and a method that tells us the burden of the character. Okay, that's the big name items, isn't it? That's what we want it to do. But we don't care at this point how it does it. Let's just start with that. Okay, so character now has two new functions, right? Carry. Well, carry has a precondition of we need to know what we want to carry, and the post condition is going to be the stuff we put in here, or the result of the stuff we put in here, which will be that person will now be, that character will now be holding that item. And that in itself makes us realize that there's more to this. And also burden, the precondition here is that this is just called, it doesn't really matter on what, and whatever it's holding, the post condition says that we will return, surely, whatever the burden level of this character is. So let's look, next level. On carry, we now realize that for this to work, we should have some collection of items. We've broken up the requirements a little bit further, and we need to be able to append to that list. Okay, I'm using list here in a very general sense because it doesn't necessarily have to be a list, as you'll see later. And in burden, what do we need? We need to be able to calculate the current weight, so something that maybe goes through all of those items and adds it up. We need to know what the burden values are. So I said in the spec it was like 25%, 50%, 75%, and so on. Well, that's got to be stored somewhere. We need a way to calculate the total capacity, which is based on strength, and we multiply it by 5. So we've got to have a multiplier. Now, we could just write 5 in somewhere, but it's better if we have that as an attribute of the character as well, because that will give us a way to have buffs, right? What if someone picks up the ring of being very good at holding, right? That will maybe increase their multiplier to 6, so their maximum capacity will go up. They're not no stronger, but they're somehow, because of this magical ring, can hold more. Okay, and we also need a way to calculate what the total current carry weight is. So that's a duplicate. I've written that twice. Current weight, current total. Yeah, that's the same thing. So yeah, I've just duplicated one. I was excited. Okay, so here is my solution to adding these things. So let's just go through character. Well, these bits we had previously, but now I've said that self.items is equal to an empty list. Later you'll see though I'm going to change that. I thought I had changed that actually. Let me go back to the source. Right, the reason for this is oh no, list is fine here. No, I changed back. I was going to have a set rather than a list, I changed my mind. Right, now forget that. A list is fine because we do want duplicates in here. So it is a list. We then have this list of things that tell us about burden. So these are thresholds. So we've got unburdened at 0.25, light at 0.5, heavy at 0.75, and struggling. This is fun, right? So this is, I realized I needed some easy way to have something that was bigger than all of the numbers. Python has that, which is this float inf. that is always going to be bigger than all of the numbers, right? It essentially represents infinity. It's a really useful trick. You don't need it very often, but there are enough cases that you do that I've used it more than once. So, just bear that in mind. And we've got here self.carry multiplier is 5. And that means that later on we could add functionality that modifies this, like I said, if we have special items that do stuff. So now let's think. Carry, well, we've broken down that functionality because we included this list of items and things. So this is now just a matter of saying append this new item onto the end. Great. Carry capacity, which tells us what our maximum is. Well, that's just self.strength times self.carry multiplier. So 5 times whatever the strength is. Carry weight, this is going to tell us what the current weight of all of the items is. So here's that pattern again. Total is 0 for I in self.items. Total plus equals I.weight return total. So it adds up the total of all of the items and returns it. Then another one here to calculate the burden ratio. That's probably what I should replace this with. A way to calculate the current ratio of weight to maximum. But what this does is it says, right, what's the maximum weight? Well, we just call the carry capacity function, which is done. We don't want to know what the current carrying weight is, so self.carry weight, and then the ratio of those, so that is current divided by max weight. So if we've got 0 divided by max weight, it's going to be 0. If we've got max weight divided by max weight, it's going to be 1, right? So that represents 0 is 0%, 1 is 100%, 0.5 is 50%, and so on. So with those three, again, broken down into these bits of functionality that we wanted, this burden bit becomes really easy because it's now going to make use of those broken down pieces. So in this one, we have ratio is self.burden ratio, so it calculates from here. And then for I in self.burden steps, which is referring to these, so it checks each of these. So each one of these tuples, which are like lists that we can't edit, if you remember, it goes through each one. So first time I will be equal to this tuple of 2 items, then it'll be equal to this tuple of 2 items, and so on. So for each of those, if the ratio that we're currently at is less than or equal to the second item in, so I1, then return the name of that. So that's the I0. Right? So if it's less than 0.25, we get unburdened. If it's less than 0.5, we return light. And you'll notice I don't even check all of the others. I just check them in order because I made sure that these always go in the right order, so that if it's less than 0.25, it will return this, and return, remember, will escape out of that function entirely. And because of that, we don't need to worry about what happens afterwards. Also, because I've got this infinity on the end, I know that I should never be able to get to this point to return anything else. If I was writing this for real, I probably would have a little check on the end to make sure I did return, just in case something got corrupted along the way. I'd probably throw an exception and deal with that somewhere else. But for clarity in this, I'm not going to bother doing that. I haven't actually changed the item at all. And now we can have a look at what happens. So here we've made a sword item. So there we go. You've got a name, a description, and if we scroll across, it has a weight, 1.5 kilos. I actually have no idea how heavy a sword would be. It's probably going to be more than that. I should have asked John. I made a character object. So here you can see capital C for character, capital I for item, which means I know these are object instantiations, not just function calls. The character is called Lilith, and she's got a strength of 2. Okay. So ch.carry sword. So I'm using the carry function, which is the one up here, which appends onto the end. Yeah, so it does that. So I make it carry the sword, and I make it carry another item. I'm just doing this differently here just to show you that I don't have to store it first. I can actually just create a new instance inside that function call, if you like, and pass it straight in. So she's going to carry a 1.5 kilogram sword called Alaroon, and she's going to have an apple, which is going to be 200 grams. Again, not a clue whether that's even realistic. I am very bad at estimating weights and distances. And then we're going to print out an F string which says the name of this character is carrying, then their current carry weight followed by kg, and their level of burden is whatever their level of burden is. Okay, so you can see along here, we've got, we do it once, then we add 3 1 kilogram bags of sugar. I'm pretty sure bags of sugar are about 1 kilogram. I have no idea. And then we'll see what it says. Then we'll add another couple of bags of sugar, see what it says, another couple of bags. And what you see is this. Lilith is carrying 1.7 kilograms and their level of burden is unburdened. Lilith is carrying 4.7 and their burden is light. Lilith is carrying 6.7 and their burden is heavy. Lilith is carrying 8.7 kilograms and their level of burden is struggling. Okay, so you can see that works. Okay, so that's I think a fairly reasonable example of breaking down a problem and trying to do it in stages. Other things to think about are encapsulation and abstraction. This is kind of what we're going for. So think about these ideas as you're thinking about how to design your problem. So if you divide the problem up, it should yield sensible groupings, right? So if these things relate to a particular set of data that has instances, so like records about employees, items on a shelf, open ports in a web server, they don't all have to be physical objects, then maybe these things make good objects. That's not a bad way to look at how to decide what the objects are. And you can create something that wraps all of that up into a simple to use object. Okay, so examples that you've seen, the collector object from last week, and we're going to use it this week. The HTTP catcher object. So that was an object that basically represents a complete web server with a very particular purpose. And all you've got to do is say, I want one of them, and I want it to listen on this port, and I want it to do these things. Done. Okay, so you can see it's a very abstract thing. Yeah, we don't have to know how it works. We just say, I want a thing to catch HTTP requests. Well, we make it from that template. And also, if you think back to the coursework, the binary object that I gave you, that was also wrapping up a lot of functionality. So that encapsulated a lot of complicated things that you didn't need to worry about, made them into this abstract idea of saying, right, that's a binary, and I can run that binary, and I can make an attempt at putting a password into that binary. Don't care how it works. Someone did that. Someone, has tested it, or at least you hope they have. I can just go and use it. So that's another way to think about how you put these things together. Another goal or another consideration is the generalization reuse. So when we make objects, generally we try to not make really specific classes. So we don't want like a class that represents people with blonde hair and a class that represents people with brown hair and a class. We can actually just say, well, let's have one that represents people, and then those attributes of that person, if they're important, can just be attributes of the objects. Okay, so you can have a person, and person.hair color might reveal the thing. It's many things are like this. So I try not to always only give real world examples of physical items. It's tempting because you can think of them as tangible things, but it could also be, like we've looked at before, ports on a web server. It could be pages in memory. It could be the binary on a disk, and so on. So think about how you generalize, and then that will help you to reuse them. Okay, so being able to do this is really important. All of the data types in Python are objects, and they're all general enough that we can reuse them, but you can make more. So Brutus.binary, it's great. We can say, okay, well, I can use this because it's a very general thing. It doesn't matter what the actual binary is, I can use it. Here's another one that I'd like to think about. Imagine we made a target object, right? This represents a pen test target. So instead of like constantly typing an IP address, what you do is you say, well, actually, I'm going to be working on this a lot, and I don't want to just store an IP address as a string or a sequence of numbers. I want to represent it as an object. And now, what could that do? Okay, well, it could actually store the IP address. It could store the results of scans, so which ports we know are open. We could even include functionality to test whether the target is still up. We could ask it to be able to produce its own text report, so what ports have been open, what scans have been run, what are their outputs. We could even then use that to pass into other things. So let's say we've got a target object and we've got a function that does port scanning, going back to an earlier project. Wouldn't it be nice if we could just pass in that object and say, go and scan that, right? And that represents a host somewhere on the network or on the internet. You could even pass it in and say, well, let's try and exploit this. Do we have an exploited version of this particular host or this particular target? So this would be really handy. So this does a few things. So it's obviously abstracting and encapsulating, but it's also generalizing and making it more reusable. Then we get on to the way we put objects together. So composition, you've seen this already. So you've had the character contains a list of items. That's composition. So it's just objects within objects. It doesn't always have to be a single item or a list. It can be either. Could be in a dictionary, could be in any other form. But example here, if we take the host object that we talked about in this previous thought experiment, sometimes hosts have multiple network interfaces. Okay, so what if the host has more than one IP address, more than one name on the network, more than one MAC address because of that? That starts to get confusing. So maybe what we want to do is have objects that represent individual network interfaces. Okay, they can store the IP address, the MAC address, the DNS record, host name, recent ping time. If we've scanned it in enough detail to get the model and chipset that's being used, that might be useful. You know, there are exploits that operate on specific pieces of hardware, like the Broadcom chips and so on. Yeah, that might be handy to have. So why don't we make that an object, and then a host can have one or more of those objects. Okay, so when we say, right, what's the IP address for that host, we actually could go, well, what are the list of IP addresses for that host? What are the IP addresses associated with that host's primary, secondary, tertiary network interfaces? So a lot more detail. But again, once we've made that interface object, our host object becomes simpler because we don't need to think about what its name is or what its IP address is. All we need to think about is the high level stuff, like what have we scanned, what services are running. And when we want to know about its interfaces, we pass that off onto the interface objects. Oh, you want to know what IP address is? Well, I've got these IP addresses, and it asks each of its interfaces what their IP address is and returns that. Okay, so that's composition. Inheritance is a different way to achieve the same thing, and it's very useful. It's not actually used as much in Python as it is in other object-oriented languages for a few reasons. One, duck typing in Python, the thing we talked about before, you can pass any type of object to anything, and as long as it has the right data and functions, it'll work. So we don't need to inherit from a common parent like you do in some object-oriented languages. And also because composition is generally preferred in Python as a sort of design choice, because it stops adding extra complexity and what we call class explosion. Right. So if you've got things like this network interface, in some languages you might say, well, if we want to be able to pass a whole host or a network interface into a function that does a scan, we'd make them both inherit from maybe a network object superclass. Python does not require you to do that. If you want to pass them both into a function that operates on things on the network, then just make sure that it uses functions they both have, right? Or make sure they both have functions that other operation needs. But when we do want to use it, it should really be to promote reuse. Okay, so if you know that there's going to be a generalized set of things that a bunch of other similar things will need, that's a good time to do it. Okay, and I've given you an example down here. So just before we move on to the example, so you inherit all of the things that the parent has. Okay, so if you inherit from it, you get all of its components. If you have something that has the same name, it gets overridden. Okay, so you'll see this with, say, the constructor. You have a constructor in the parent. You also have a constructor in the child or the subclass. But it's the subclass one that will be used when you create an instance of the subclass. So if you have something of the same name, it's the new version that gets used. It doesn't mean you lose access to the other one, but you have to think about how you actually operate on it. And I've given you an example here that does that. So,
sorry, James, can you
go
over the self-dot, how was it, burden steps syntax? Because it was weird and it didn't seem familiar to me.
Yes, I tell you what, let me scroll back up and find it. So, self.burden steps is a list, starts and ends there. Okay, and inside that list, it has tuples of 2 items. Each one of them is the name of how burdened someone would be, and then the fraction of their carrying that is the maximum before they are considered not to be that anymore. So up to 0.25. You are unburdened. Up to 0.5, you are lightly burdened. Up to 0.75, heavy, and so on. And so it's just a list of tuples. Now, the checking of which one we use down here. So first of all, we work out what our current ratio is. So let's say we could carry up to 10 kilograms, but we're only carrying 1.5. What this does is it goes through each of these pairs of things and checks their current ratio of 1.5, for example, against the first, as in the second one along item. So it goes, is it less than 0.25? Yes, in which case we return the item in the 0 position. So that would be unburdened. If our ratio was, say, 0.74, okay, it would go through the same loop, and it would be I would be self.burden steps. It would first be this one, and it would check to see if it. Hold on, the mouse has just stopped moving. That's weird. The touchpad works. Oh, okay. Sorry. Dead mouse. Right, that's going to be fun. It's really dead at all. I only changed the battery yesterday. It goes for months without needing changing. Okay, right, trackpad it is. So when it comes through with 0.74, it would then skip over the first one after checking whether it's less than 0.25, which is not. It would then check to see if it was less than 0.5, which is not. It would then check to see if it's less than 0.75, which it would be. And so, sorry, scrolling with the touchpad. And so then it would return the 0th item for that. Does that make sense?
Yeah, but the program basically checks the second item in the tuple. Okay.
Yeah.
And how does it do that? Because it's not an integer or a float in this case, and it automatically skips the strings and just checks the.
Okay. So I is each of these items as a pair. Okay, because that's a list. For I in self.burden steps means the first time it will be this pair, then it'll be this pair. My mouse started working and then it stopped again. All right. Then it's this pair. Then it's this pair. And then it's the last pair. And so when it says if ratio is less than I1, it's actually checking this bit in each pair first. And if the current value is less than that, then it returns I0.
Okay, so basically in the if condition, the I is the tuple, is
yes,
basically,
exactly.
and in the return is the list.
That's
okay.
it. That's exactly it.
Okay.
Okay. Right, so let me run you through this example. So in this example, we've got a class called shape, and sorry, I keep wanting my mouse to work. It's really driving me mad. This class has an initializer, a constructor, which is there we go. Right, so here we have the init function. And this just says self.pixels equals a set. Okay, so this is like a list, but instead of allowing you to have duplicates, it automatically removes any duplicates you put in. Okay, so like a set in maths, and it has a couple of functions. I'm going to leave this one out for now. I'm going to tell you about that in a second. But the function it has mainly is render, which is to render a shape. Okay, so this is a generic shape. And what it does is it goes through this collection of pixels, which are going to be tuples of x and y. Okay, so it's going to be, like, say, 4, 5, which means 4 to the right and 5 from the top. And if that exists in the list, it will output a hash at that point. And the way it does this is it starts off with an empty string, and then for each line in that, it goes through each of the possible points on that line, and it checks to see if pixels holds that value, right? So does 5, 4 exist in a set of pixels? If it does, we add a hash. If it doesn't, we add a space. And it does that for each line, putting a new line in afterwards, right? Ignore this one for now. I'll come back to it. And then we can create a square, okay? And again, ignore everything below. I'll talk about those another time, today, but shortly. So our initializer is different. So it says here we have an X position, a Y position, a width, and a height. Okay, now this inherits from shape. So it's got an init, and we do actually want to use that because we want to make sure that it does this self.pixels equals set. And this is how we do that. So I said we could always get access to them. It's quite simple. We just do shape.init self. Okay, so it literally just calls the function from the class that we want it to use, and we pass self in. Okay. Then we're going to go through a loop, and we're going to go through the height and width. So this is the width and height that were given for this square. I mean, technically it's a rectangle, I suppose. Should have called it rectangle, just realised. But it's kind of the same thing. We just have a size instead of a height and a width. But we go for y in range height for x in range width, and we add to the pixels x plus x pars, y plus y pars. So it's going to go through, let's say we say it's going to be a 5 by 5 square, then width and height are both 5, and so y will go 0, 1, 2, 3, 4, and x will go 0, 1, 2, 3, 4 for every one of those outside iterations. Okay, so we'll have 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 2, 0, and so on. Yeah, that makes sense, I think. And then we add that as a tuple, but we also add xpos. And what that does is it means that if you wanted a 5 by 5 square, but you want it at position 2, 2, it's adding 2 to each of those positions. So it just shuffles it to the right place. Okay, now ignore this one. And no. Let me, I'm going to leave my mouse, so I just need to get it on the battery. Okay, back and working mouse. I don't know whether my mouse is on the way out or the battery wasn't charged as much as I thought it was. So what I'm going to do is I'm going to copy this and put it into Emacs for a second, so we can look at how this works. So I don't really know why I've copied it from there because I've got it here, but anyway, copy from there. Yeah. So there is the code. Run it, and we get some shapes. So let me just go back and simplify what we're doing for a second. So let's just make a square object. We'll ignore the circle for now, and I'll explain that in a second. And let's take that out. And we're going to print out the square.render. Okay, so that was that function that goes through and draws the hashes. So let's see what we get. We get a square. Okay. Or actually, we do get a square of 5, 5. It doesn't look like it because these aren't actually real pixels, they are characters, and the characters are not square. So it's a square in one sense, but yeah, it's like having a squashed aspect ratio. Okay, so that works, but the good thing is, a square, all it needed to do was work out what pixels are inside a square. Okay, so all of the rendering part was already done for us, and that means we can also do things like, let's do a circle. Okay, so if you look what I've done here is I've created a distance function. It's just using Pythagoras, so it's the difference in x squared plus difference in y squared added together, square rooted. Okay, so if that makes sense, that's great. If not, don't worry about it. Just go back and look at GCSE maths at some point, and I'm sure it'll make sense. But to work out whether something is inside a circle, all we need to do is to go through all of the points that are sort of in the square around the circle, and any that are less than the distance. Any that are less than the radius in their distance from the center, therefore must be inside. Anything that's greater than that must be outside. So what I've done is gone from minus the radius to plus the radius in x and y, check to see if the distance between 0 and that point is less than the radius. If it is, we add it. And again, we add x pos and y pos because this is calculating as if the circle has its center at 0, 0, and then we just shift it across to where we actually want it. Where is its x pos? Where is it y pos? Okay, so let's just create the circle and let's render the circle instead of the square. So let's see what that looks like. Great, there's a circle. It's not a great circle, I admit, but yeah, it's kind of there. You can try making these things bigger if you want to. So let's make the radius a bit larger. Look a little bit better. Look. Yeah, so this looks slightly more circular. So you see that we can build these shapes and they can render themselves quite easily. You could easily make rectangles, triangles, what have you with this. Great. We can also do some clever stuff then, right? So look at this thing. Okay. Add says we're going to make a new shape. We take in something else. So this is to add to itself. Remember the double underscores. So this dunder with add in the middle is the one that's used when we do something plus something else. So this is actually overloading an operator now. So what this does is it creates a new shape, and it says the pixels in the new shape is the same as the pixels in the current shape unioned with, and this is why I used sets in this one, the other shaped pixels. So it just joins them together. And that means we can do really cool stuff like circle plus square and render that. Okay, add the two shapes together. And there it is. Okay, circle overlaid with a square. Okay, what else might you want to do? What about the difference between them? Okay, well, what else can we do? We can look in Python 3, help, what can sets do? We can do all of these things, okay? So we've got difference, we could try difference, we could do that with divide, okay? So what's the difference between the two? So def, div, self, other, and very lazy and say it's the same as this difference. So now let's see what happens if we do circle divided by square. No, it's not. Oh, is it div? Isn't it? Hold on, let me just check my. Okay, not div. Don't subtract. Hold on, let me look it up. So I'm trying to work out which operator, which double underscore function is the one that implements the division operator. So Python 3 operator divide overloading. Okay, so Python 3 it seems to have changed. To what though? That wasn't particularly useful. So division changed a little bit in Python 3, which I think is probably why. So division true div. Okay. In Python 3, just as an aside, 1 divided by 2 gets you 0.5. In Python 2, 1 divided by 2 gets you 0. The reason being, in Python 2, integer divided by integer is an integer division. In Python 3, integer divided by integer is a true division, which explains why they now call it true div. So there we go. There's a change I didn't know about and didn't expect, but hopefully you can now run this and we find what the difference is between one and the other. So let's do that the other way around. Let's try, instead of C over S, let's try S over C. Yeah, and now we get the thing will move the other way. We should also have, we've got multiplication. So let's have a look and see what we might want to apply to multiplication. So I think that should be the intersection. Okay, so that's the things that's in both. Let's add that operator. Mul. So intersection multiply two shapes together. There you go. You get only the bit that's in the middle. So by having that superclass, we are providing all of our classes that inherit from it a way to make the most of what's there. Yeah, to be able to provide just the functionality that's different and be as reusable as we can possibly make it. Okay. Right, there is some further reading on these things here, so feel free to go and have a look at those. And the breakout, which is what we do now, is you're going to look at this second part of this, and this is also your project work for the week until Wednesday. So your phase 2 of this is that you have another branch, right? There is an objectified branch, which you've seen me talk about earlier. And what this does is it adds a few things. So we have collector and we have catcher. Collector is provided for you. So let me show you the code. So that link there takes you directly to that branch, but you can just do a pull and a remote branch switch like you did before on the version you've already downloaded. So the collector, you remember hopefully from last week, this collects up data that's potentially encoded. So it's got its initializer, that stores an encoder, potentially uses the default encoder, which does nothing. We can append data to the end of it. So we can add new data, which will be decoded. We can find the length. We can add two of these things together, and so it will combine them. And you've got some basic, show me as a string, show me something else. And there's some, you can run this to test it out a little and see what happens when you combine things. Great. So you can see, we append multiple things, we get that, no problem. Okay. What else? You also need to implement the catcher. Now, this one currently has empty functions. And what this is going to do is it's going to represent on the side of the server something that will collect up the data for a specific file and record whether it needs to be saved and save it if necessary. Okay, so what does it need? It needs to have a stored file name. Okay, so this is the file name that you want to look out for, like data or password or whatever. It needs to make its own collector object, so that's going to reuse all of that stuff that you saw in the other class, so you can just add to it quite easily. It needs to know whether it's dirty or not. This is a term used when we're writing things to disk or to memory. It's dirty as long as it's been changed but not saved to disk, at which point we call it clean. Okay, so dirty will be true if the data has changed but is not false, and false if the data has either not been added at all, so it's just empty and never started, or you've appended data into this catcher object but you haven't yet written it to disk. The path is going to be the directory plus the file name that it should save to on disk. The functions you need: append, write, and length. Okay. These will make use of, append will make use of the collector object, so you'll be passing the data through to that. Write will take the data out of the collector object and write it to a file, which you've got an example of in the previous version, which you'll still have access to. It's on the master branch. And length, which will return the length of the collector object that it contains. So again, you can just return the length of its own collector object. These things will be used inside Xalice. Okay, so look down here at the bottom. You can see now the way we use this is we create catcher objects, right? So this catcher will catch things that come in for password. It expects them to be base 16 decoded, and they'll be saved in output. This one takes shadow, this one takes temp. We then can put these in a list, and what we can do is we can handle the request passing all these in, and we can go through each time and say, right, this has got a path and it's got a length, and we can check whether it's saved, whether it's dirty, and what have you. In the actual code, you can see what happens here is we check to see, do we have a catcher with that file name? If not, when we set it to none, and we check to see what the commands are. And I can show you this running as it should do. If you just give me a moment. Thanks for trying to oh. me just make sure bring in the main repo. Good. Okay. And then so it runs and is silent the same as it did previously, and we can now use Xbob. So I'm going to just switch this one as well. Check it. Right. So now Xbob says that you've got to give it exactly one file name from which to read data, or set a target file name on the other end and request that it's written to disk, or that you want to quit. So it's got more options. So what we can do is we can say that, for example, here I want to run, I want to send something to XPassword, and there we go. So the file name is password, and the file I'm going to send is XPassword. So there we go. So you can see it sends chunk 0, 1, 2, 3, and 4. And over here, each time it sends a piece, it actually tells you what's going on with it. So you can see output password has 2150 bytes and it is not saved. Output shadow has 0 bytes and has been saved because it's not dirty, it's got nothing in it. And you can see after each one of these, it totals those things up. So at the moment, they're not written to disk. So what I want to do is I want to tell it to write to disk. Okay, so to do that, what I would do is I would pass, again, I'm working on the password catcher and the -w switch will write, and it says requesting writing. And over here, you can see the update now says that output password has 2150 bytes and has been saved. Now I want it to quit, and it quits the remote thing. So my client can now have a lot more control over what's going on over there, and I have predefined catchers that have functionality. So it's simplified the process. It still, has lots of work need to be done to make it perfectly useful, but it's all there. Okay, so we've gone from being on time to not being on time. I shouldn't have been so cavalier about giving you time to have a proper break. However, it doesn't matter a huge amount because this is meant to be the work you do between now and next Wednesday anyway. So the break session was just to catch up. Right, so do we have to do this task question is a really interesting one, because no, you don't even have to do the coursework, but you will fail. Okay.
I was going to say, I did say to Simran that it's like inextricably linked this time around, this specific, thing today.
All of these things are building up your programming experience and knowledge. Okay, so when I say, this is just a project task, it's not part of the coursework. If you don't do it, I'm not going to know, right? I'm not going to be looking, coming around your house to check up on it. I'm not going to, tell you off about it. But I can guarantee you will find the next project harder, and that one will be assessed. Okay, so all of these things are practice. Yeah, exactly. That's it. General practice. Most of the things I put out there are for exactly that. Okay.
And the next piece of coursework is going to be like including classes and object-oriented programming.
Exactly.
So you guys are really going to need it. Some of you have expressed that you're struggling with this task. Do the same thing that we always say to do. Go back over the video, watch it again, make sure you feel comfortable with it. Come and ask us questions.
Yeah.
And
remember, the key thing is you fill in that one class, right? Everything else is working. Everything else is there. You just need to fill in that one class. Okay. Ideally, you also write the tests and the documentation for it, because you'll need that in the coursework as well. So get you practicing on those things too. But yeah, James, why can't you follow along with the videos? Oh, hold on, Bogdan, I missed yours. Do we need the requests? Actually, that's really interesting, because I don't know. You're going to get some freedom on what you do. Some of you will use requests, some of you might not. There will be some of the things that you do will be sort of considered the basic tasks, will give you a lot more guidance. Some of them will be a little bit more open, and those will be the intermediate and then advanced tasks. Some of them will be completely up to you what you do with it, but you're going to be building bits of functionality. So James, the thing about the video is hopefully you can go back to the video and stop it at certain points, right? You can stop it and go, I didn't quite understand what that meant. Maybe if I go and try the example, right? Can I replicate what's going on? If you can, that's going to probably explain quite a lot. And if you can't, it highlights where the problem is. And what you can do is you can then come to us, you can either message us in Aula or Teams, or come to the Monday or the Friday sessions and say, I got this far, and then I got stuck. Okay, so you know, what am I getting wrong with this? Or this is what I thought that meant, but then when I try it, it doesn't seem to work. Those kinds of questions, they're brilliant, because they tell us what your thinking is, and we can start to help with it. But you know, it's better to have a go and fail, and then come and get some support on that fail, than to not try because you're not sure about where to go all the way through. Better to give even the first few steps a go than not.
Yeah, I would double down on what James just said. Like, we generally we can help more if you've given us an idea of what you've already tried and what you expected to happen and why you think it didn't work. Because then we know what you're thinking and we can guide you. And that's true even if it's like coursework related stuff. Do you know what I mean? Like, we don't have to give you the answers, but we certainly can sort of point you in the right directions.
Yeah. Simran, yeah, it's not everything. I mean, there's going to be new things, you know, in the new project, but certainly you're going to be using objects. You're going to be passing objects into things. You know, you're going to be creating, you know, bits of functionality. The idea of the next project is that you're going to have a framework for a local enumeration and privilege escalation tool. So, when you're doing pen testing, you know, definitely not be doing evil hacking, you know, just pen testing. You sometimes want a bunch of little tools and things to enumerate what's there and to execute a few you know, exploits on systems. And what you're going to do is you're going to build a tool that helps you do it. Okay, and the way we're going to do that is we're going to give you a lot of the framework, and then you're going to use your now experience in programming and creating these things to create some objects or classes that can be used inside that system. Okay, so you know, what you actually implement will be a little bit up to you. Each person in your group will be doing different things, but they all have to work together. And so, you know, everyone should end up with something slightly different, but of the same sort of level of complexity.
I'm a little bit confused by what the Leap task is. Is it like a privilege escalation tool? Is that simply it?
Well, it's enumeration and privilege escalation. So the idea is that you'll be able to do things like, you know, tell me all of the things I can execute with sudo without needing a password. Tell me all of the files that are, you know, readable by me at this user level, or list all of the users on a system, or show me all of the open ports on this system. You know,
so would it
scanning.
want to collect the information of the system, so things like OS's software, their versions, etc.?
That's it, exactly that. A good example, okay. I just quickly switch over here. The high on coffee enumeration script is one that I quite like. Well, I think lots of people like it, actually, not like it's a secret. But there is a, I don't want that, I want their script. There you go. So that script, which is really quite nice. So I'll just get the URL. So if I run it on this system, for example, it will tell me all the sort of interesting things. So I'm going to download it to the local system. I don't normally recommend downloading things to a machine that you're using off the internet and running them blindly. I know this one I used a lot. Normally I'd be using this in a target. But so we've got this file, and I can run it, and it will then do an absolute ton of stuff. Okay, and what it's going to do is it's going to tell me all of the interesting things that I might want to be able to break in further to this system, or to find some useful stuff. So it's you can already see it's telling me who's in SU doers, except it can't because it's actually secured. It gives you a list of the group contents. Can't get into Shadow, which it shouldn't be able to. If I could, that would be a very useful thing to know. Shows me the contents of X password. Shows me what's in FS tab, which is the file systems, what's currently mounted. So you can see file system info, network info, so what the name servers are. So all of this really useful stuff, and it just keeps going and going and going and going, right? So there's tons of it. Sticky bit files. So these are things that can be run as a standard user, but actually, will give you root privileges when you do. Nothing there looks particularly wrong, so that's not really going to help us get in. I don't need to.
Should it be able to escalate your privileges, or should it just show you how, sort of thing?
Your tool will hopefully be able to escalate some privileges. It depends on the situation, but I'm going to give you a target system that's going to make it easy to do a few basics, and we'll be able to do a few more complex ones if you look for them. But I don't even mind if people want to sort of craft exploits into their own target systems beyond what I put in, just to demonstrate some more fun stuff. But there will be enough to go on that there'll be plenty for you there. And you don't need to do all of it. You need to do like a few of them each, really. The exact numbers will be in there, but yeah, this is you're not expected to write something that does as much as this. This is quite a fulsome and useful script. So don't feel like you have to do it.
I must admit, I use my own version of a script. For High on Coffee's one really nice, but it's a bit overkill for most of what I end up doing. So I've got stuff that I would use. Does that make sense? So hopefully you guys can also build one of those for yourself.
Just one last thing, James. How do you want people to contact you for the pairings of the group?
I haven't worked it out yet. I will.
Okay.
I'll put a note on Aula and explain.